We're going to start today by looking at these four different linear functions and finding their zeros. And once we've found their zeros, we're going to combine a set of these, either in groups of 2, groups of 3, groups of 4, and try to use those zeros to describe what happens with rational functions. So let's take each of these, find their zeros, and then combine them. So if I look at this x plus 1, and I want to know what makes that equal to 0. Well, that one's going to be a negative 1, because negative 1 plus 1 would end up giving us a 0. If I go down the line here, this one, the 0 would be at 2. This one, I'd have to subtract 3 and divide 2, so that's going to give me a negative 3 halves. And this last one, I could say the 0 is at 1/4. Now, by themselves, they aren't going to help us much, but as we combine these together, we'll start to see what these zeros represent for different types of functions. So let's go ahead and take a look at f of x and g of x combined. So if I were to divide it by g, and create a new function with those two, I'm going to have the x plus 1 in the numerator, and I'm going to have the x minus 2 in the denominator. Now, when we talked about basic rational functions, we didn't have an x up in the numerator, but we did have x's in the denominator. And that helped us see a horizontal shift. So in this case, that's going to be no different. We're still going to shift to the right 2, as we see with the 0 here, and it describes the exact same thing that it would have with the previous functions. I can say that my vertical asymptote on this is at x equals a positive 2. But what do we do with the numerator, the x plus 1? I still am going to consider what the 0 is there, but it's no longer an asymptote. I can describe that as my x-intercept is at negative 1. So looking at this fraction, the 0 of the denominator becomes my vertical asymptote, and the 0 of my numerator becomes my x-intercept. So if I were to flip these, let's go the opposite way, and put g on top, put f on the bottom. I've got x minus 2 now over x plus 1. I still know the zeros are positive 2 and negative 1 of the two factors, but positive 2 is no longer an asymptote, it becomes the x-intercept. So my x-intercept now is at positive 2, and my vertical asymptote now is at x equals negative 1. So because of that switch of the denominator to numerator and the other way around, the vertical asymptote and the x-intercept also got switched. Now, we don't want to just describe vertical asymptotes or just describe the x-intercepts. We also want to be able to figure out what is the y-intercept for each one of these, and we want to be able to identify what is the horizontal asymptote for each one of these. Now, for the y-intercept, anytime we're finding a y-intercept, we plug in a 0 for x. Because if we think about a graph, a y-intercept happens when we're on the y-axis, and that's where x equals 0. So if I took this function and plugged a 0 in for each one of those x's, I get 0 plus 1 in the numerator, 0 minus 2 in the denominator, I end up getting a negative 1/2 for my y-intercept. Similar thing here, if I plug in the 0, I get 0 minus 2 over 0 plus 1, ends up giving me a negative 2 for the y-intercept of that function. Now, horizontal asymptote, we need to do something that we haven't done before, because if we look at this function, it looks a little bit different than how we worked with the basic rational functions when they transform left to right, up or down. Because we don't have that plus or minus value out back, and we have an x value up in the numerator. So I'm going to look at the highest powers of x's here, our x over x. If I were to divide x by x, I end up getting a positive 1. That tells me that my horizontal asymptote is at y equals 1. Or over here, I have those same values of x over x. If I divide those out, I end up getting, so my horizontal asymptote is at y equals 1.